Hello, in this session I'm going to be talking about data vault indating. What we're going to cover today is, I'm just going to briefly talk about data vault indating and just explain briefly where the history of it and where it comes from and the conditions for it. Then we're going to look at performance considerations of loading with indating and without. And then lastly, I'm going to show you how we actually configure satellite indating or not indating inside of BimlFlex. So in preparation for this webinar here, I was looking at, indating, where does it come from, how does it evolve over the time, and in the different blogs entries that I could find. And the first one I could find was in about 2001 to 2003, there was an article written by Dan Lindstedt that explained, that you can have two approaches to indating, one in point-in-time tables and one in satellite tables. And at the time, most of the reasoning behind it was to extract the data from satellites using a between statement, because some of the data warehouse software at that time didn't really have good sort of CTE functions or common table expression functions like lead and lag, where you can go and derive the end date sort of in a SQL query. And then moving over, we then have a look at there's a number of articles out there around how do you implement it and various different flavors of it and when to use it and how to use it. On Roland Voss's website and Hans Mikkel's website, there's a couple of articles there that I read through and just to see the different approaches, and they are fundamentally the same but slightly different. And then the last one here was again updates in Data Vault Update finally from Dan Lindstedt, where he goes about and saying, you know what, if you want to be preparing for the future, you shouldn't really have any updates, and indating is a form of updates because you load the data and then you say, well, going back into the satellite and go and insert updates. And then lastly, now in 2018, and my view of this is there are, when you read some people's articles on the web, some people have very strong views for or against it. What we've done is we've said, well, you choose. I've been in the data warehousing world long enough, and I've been implementing data vault long enough to know that not one size fits all. There are when every project has different requirements, different needs, and in some cases you may want to indate, in some cases you may not want to indate. So having the option to actually choose when it makes sense or when you want to use one approach versus different ones is far more powerful, and having a framework that actually allows you to do that is far more powerful than actually saying, no, I'm not doing it or I am doing it, right, for all cases. Having a blanket statement like that, I don't think is the right approach. So let's have a look at it. Obviously, with indating, there is performance considerations. You ultimately are going to load the data, and you're then going to run an update statement that could be quite a heavy load. Now, what you need to consider of when you want to use it or not, are you loading in batches, or are you loading in real time or near real time? Real time is obviously quite relative. When you're loading near real-time data, and what I mean by near real-time data is you're connecting to a source system and it can tell you the rate of change based on a last modified date. Sometimes you may have to, you'll extract it, but your real time is actually 5 or 10 minutes behind because the source system can only give you the data in that frequency. Then you have change data capture. You've got SQL Server with change data capture. Well, again, near real time means that yes, I can poll that server, but I'm only going to do that every 5 minutes. There's no sort of message queue coming out of there. So that's batches and near real time, which in my opinion, in that context, is near real time is really just a more frequent ETL batch and a smaller batch. Then that's the data coming in. The data going out, you need to analyze the speed in versus speed out. In other words, if you're loading your data once a day, you could slow down the data in, and if you are then using that data in your data vault, and you are now publishing it to multiple data marts. In other words, the data out needs to be fast and be reliable because you are taking the data that came in once, you're distributing it and federating that across multiple cubes, multiple dimensional data marts and stuff. Your speed out of your data vault becomes more important than the speed in because you can slow it down in the beginning and speed it up at the end. Right, so that's what you need to do, and then also you need to be able to say, well, let's just say I'm building a lot of current only, which I want to track all my history in my data vault, but my data marts may only be current. It might be a type 1 data mart. Therefore, the ability to look at my data vault and identify the latest row in every single satellite is very important. So therefore, again, indating your satellites may be the right thing to do. Now we move on to, well, we look into an insert-only architecture. Now, the insert-only architecture, I personally recommend this only when you are adding other methods for actually getting that data out. So insert-only architect is by far my recommendation. And this leads well to things like when we are polling a source system and just pulling the data out and pushing it into a stream or a event hub. Now, a stream for me could be, obviously streams that is in event streams and things like that. But it could also be just streams of data. In other words, streams of flat files. So I can be polling a source system, pulling a small amount of data out using some form of chain data capture, and dropping that file into an Azure data lake or into Azure blob storage, where my second process is completely disconnected from my first process, and it sees it similar to a stream where you're using Azure SQL Data Warehouse, or you've got Azure VM that are using Polybase to load that data into your data vault. And again, you want to stream that in as fast as you can, and then therefore you want to have an insert-only architecture. So there's different considerations. So again, I think just by that explanation, you can see that I'm leaning towards not one size fits all. Then the next thing you want to do is also take in consideration, are you creating physical data modes or virtual data modes? Now, if you are creating virtual data modes, that means that every single time the query is run to select data or extract data, you need to go and do the join clause, and you need to go and derive the indating. So if you are using a lead function or some form of a CTE function that derives the end date and gives you the right between statement for virtual data modes, you either going to need to either have very powerful hardware, or you're going to need to put a layer in the middle there, like a business data vault layer, where you are putting bridge tables and point in time tables, or even additional satellites there to derive values for you. So for me, those are all the performance considerations. And personally, I don't think when you start a data vault or start a project that you'll have the answer to all of these things on day one, right? These things will evolve as your project goes on. So having the ability to selectively switch things on and off as you model and as you work through your project is very important. So just having obviously you want to go into the project with a standard, saying we are either going to do insert only, or we are going to do have indate on all of our satellites, and then the exception is whatever the one is that you didn't choose as your standard. And I'll show you how you can implement this very shortly. There are also other satellite considerations that you need to take in consideration that may or may not have an effect on the first decision. The one is record condensing. What record condensing means is that, let's just say you are loading a chain set of data, and on a satellite you have 50 rows that came in that single batch. And out of that 50 rows, because you've split your satellites, out of that 50 rows, there may only be 5 net changes. So what record condensing means is that what you want to do is you want to say, go and sort of throw away the records in the middle that hasn't got an actual physical change on it, because those changes may be on a different satellite. You also want to take in consideration whether you've modeled any satellites to be multi-active. And multi-active is normally where you have multivariant primary keys. So you may have a table in your source system coming through that says, oh, I've got a CRM system, and that CRM system is telling me that this record was active between this time and this time. And then that sort of start date from that active, from that table becomes part of your satellite key, becomes a multi-active key. Now, you'll see also in this presentation, I have these sort of bit.ly, these small links here. What I've done is that on the web there, the multi-active one there is a link from Dan Lindstedt, where they explain what is a multi-active satellite and what is not a multi-active satellite, and what is a multi-active key and what is not it. Right? So please be aware that there are lots of articles and blogs out there that goes into each one of these mini subjects in a lot more detail than I am. And then satellite splitting. Again, when you model your data vault, you want to look at your data, you want to profile your data, you want to actually understand your data, because sometimes, or most of the time, when you have a very wide satellite, so, sometimes you work with ERP systems where they have a 200 column customer table. And in that customer table, that there's a lot of change there. There may even be a sort of a customer balance on there. So every day the customer's balance changes, or you have 500 customer balance changes through the course of the day. But that may be only on one column out of that whole 200. So what you don't want to do is you don't want to go and duplicate and replicate those columns all the time. So understanding how to split your satellites, possibly on geography or on the type of the data. In other words, are all my dates going to one satellite or all my amounts going to another satellite? Then the next one, probably the one that we recommend most often, is to try and find, especially if you've got a persistent staging layer where you can kind of see how your data is changing. Run some profiling scripts on there to see how fast is the columns changing. So you may have columns that are fairly static, you may have columns that are changing frequently, and what you want to do is try and find a sweet spot where you want to go and split those satellites up and say, well, these columns change quite fast and these columns doesn't change at all. So you get a lot of changes coming through, but it may be on data that may be on only certain columns of it. So splitting a satellite is definitely something that you want to consider for performance. And then the last one is linked satellites. Again, there's quite a lot of articles and posts about linked satellites, whether you need them at all. I'm talking about a linked satellite here purely to capture effectivity on a link, when the relationship was active. So linked satellites will capture effectivity. For that, you'll need to obviously take in consideration driving keys of which part of the link. If you've got a unit of work that's got 5 hubs contributing to that unit of work, 2 of those hubs may be contributing to the driving key. In other words, they decide whether the other things are changed or not. And again, there's a link there to go for it. So what I'm going to do is I'm going to show you a BimlFlex demo now. And in this demo, I'm going to look at a couple of different things. So with BimlFlex, you can go and configure your ETL pattern to be SSIS, in other words, ETL. In other words, we can go from, source to staging. In this demo has already been done. So I've already done the source to staging. We've already modeled the data vault. So I have a table, and I've just used the sales order detail table from AdventureWorks LT. And I've made it a lot larger, so we've made it 20 million plus rows, just so that we can get a rough idea for you about, the time it takes for the indating in comparison to the rest of the load. So I'm going to build a SSIS package with indating. Then I'm going to show you how we toggle that off, and then I'm going to build an SSIS package without indating. I'm going to run all of those, and I'll give you the performance for that. And I'm going to show you how easy it is to change from using an ETL pattern, in other words, an SSIS-based pattern, to an ELT pattern, a SQL-based pattern that you can obviously then run in the Azure cloud, or when you're looking and using Polybase, you would be using your ELT pattern. I'll also explain to you the difference that in a project, when you are building a data vault, you can selectively choose the pattern for a specific table. So in other words, let's just say you're extracting 100 tables, you may choose that 90 of that 100 tables are using the SSIS pattern and 10 of them are using the SQL pattern. And again, the reason for that is because we want to give you the choice that when you are looking at your project and you're looking at your performance, you can decide which one of these patterns out of these 4 different versions, which one of them is relevant to which part of your data. This is not us saying that we believe you should do it one way. We believe that you should know better and you know best about how to actually extract your data. So without further ado, I'm actually going to go switch over and actually do the BimlFlex demo and show you how all of this comes together.